Okay, today's lesson's on 5-7 roots and zeros. So basically we are going to use what we talked about yesterday with 5-6 and 5-5 factoring and so on. We're going to kind of putting it all together here as we go along with this chapter. The first goal is to synthetic types of roots. And so basically it's just in general type of a concept here. But P of x is equal to a sub n, x to the n, and so on. This is just, all this is a polynomial function. It's just the general form of that. A sub n is the leading coefficient, n is the degree, and so on. It says here that if a zero of P of x is c, we know then by the factor theorem that P of x, or P of c equals 0. We also know then that x minus c is a factor of P of x. So if you know it's a 0, you know the remainder when you divide by x minus c is a 0, you know that there is an x-intercept at c0, the graph of, on the graph of P of x. So what we're going to do here is we're going to go over just a general type of a polynomial and talk about these things with it. Okay, so I'm going to go ahead and move the camera over to this one. We're going to use the calculator and just talk about it. Okay, so at this point, using the fact that we have a polynomial. First of all, we know the degree of this polynomial is 4. The max number of zeros I've talked about already is 4. Now, according to in this section, now I've already mentioned this ahead of time, but in this section there's something called the fundamental theorem of algebra. And the fundamental theorem of algebra basically says that when you have a polynomial, there is at least one zero. If you read in the book and the next page, it talks about a corollary. So this one says P of x has at least 1 0. The corollary says there is n number of zeros, real and complex. Or I should say complex zeros, real and imaginary. So, since the degree of 4, we know there's a max number of real zeros of 4, but the total number of zeros, real and imaginary together, is 4, according to the corollary of the fundamental theorem of algebra. Okay, so let's go ahead and just look at this. Let's look at this polynomial on a graph. Let's look at the table. Let's identify some things that we know. Okay, so I've already put this in my calculator. Y equals. Okay, so then we go ahead and go to the table. Now, according to this, we should be able to find 4 zeros if they're all real and they're all integers. Okay, so let's go ahead and do this. Let's see if we can find some zeros here. Okay, it looks like it goes up significantly, so there's probably no zeros there. There is 0 right there. So we know that there are probably 4 zeros. We don't know if they come up more than once, each one, but we do know that -2 is at least one of the zeros, according to my table. I also know that 1 is a 0. Okay, so we're always looking for the same number of zeros as the degree. Oh, it looks like 5 is a 0. And we're looking for another 0, knowing that there's probably 4 of them. Now, I also know that this cannot be imaginary at this point. And the reason this cannot be imaginary is because you have to have 2 imaginary if there's any at all. 2, 4, 6 imaginary. They have to come in pairs. So I know this has to be real. Whether I know it's a repeating 0 or not, I don't know. Whether it's just another 0 that's maybe irrational or rational, that's a fraction other than integer, maybe that's the case. So let's go ahead and go to the graph. And so here's my graph. I know this is my -2. This is my 1. This is my 5. Looks like there is a 0, a real 0, right here. I don't know what that is, but I'm going to try to find it. On the calculator, I can possibly find it using my calculation key. Okay, so I calculate the 0, left side, right side, and according to this, my 0 looks like 1/3. So 1/3 is my other 0. Now, there are other ways of doing this besides using the calculator, and that is using factoring. Since we use the calculator to know that these 3 zeros are there, what we can do, and you're going to be doing this more than you think, we are going to use what we talked about last section and divide out the factors. X plus 2, x minus 1, x minus 5. Whatever's left after I factor these out should give me that as a 0. So that's another way of doing this. So I'm going to go ahead and factor out x plus 2 using synthetic division. Okay, I should get a 0 right there because x plus 2 should be a factor and -2 should be a 0. So I should get 0 for a remainder. If I didn't get 0, I'm doing something incorrectly. I'm just going to double check to see if the camera's in a good location. Okay. All right. So let's go ahead and try this. We're going to drop the 3, multiply, add, multiply, add, multiply, add, multiply, and sure enough. Now, I just factored out x plus 2 out of the polynomial. It leaves me with this polynomial. So basically what I just did was I took x plus 2 out and it left me with 3x cubed minus 19x squared plus 21x minus 5. Now I'm going to factor out of that x minus 1. That will leave me a quadratic. So all I'm going to do now is I'm going to go like this, put a 1 there, drop the 3, and again I should get 0 here because 1 is a factor, or excuse me, a 0. 3, -16, -16, 5, 5, and 0. So basically what I just did there was I'm left with 3x squared minus 16x plus 5. Now the last thing I'm going to do is factor out of this quadratic an x minus 5. Now I probably could do that easily by hand, but I'm going to go ahead, since this is already set up, I'm going to go ahead and put a 5 in here, and I should get 0 here. 3, 15, -1, -5, and sure enough, that leaves me with 3x minus 1 as my remaining factor, which of course, when I set that equal to 0, will give me 1/3 as my other zero. So if you know any zeros at all, you can factor those out and use dividing or factoring to get it broke down further. Okay, so that's a concept you're going to need to know. All right, so after this, let's go ahead and do a couple problems. Let's go ahead and do 1A. I'm going to move the camera so we don't get too much of a glare. Okay, so 1A says, the directions say it says solve each equation, solve the number, or state the number and types of zeros. Okay, so we're going to go ahead and solve these. All right, so we've got 1A here, which is x cubed plus 2x equals 0. I've got 1B here, which is x to the 4th minus 16 equals 0. 1C is x cubed plus 4x squared minus 7x minus 10 equals 0. And then 1D is x cubed, 3x cubed minus x squared plus 9x minus 3 equals 0. Now, what we're going to do here is, if we're going to find the zeros, we're going to try to factor as much as we can. It's so much easier, faster, and everything, so we're going to do that because it's not going to help us to look up irrational numbers on the calculator. It just doesn't, it's not going to get us anywhere. So if we can factor, we're going to be a lot better off. All right, so the first thing I'm going to do is try to factor this. And I'm going to take an x out. Now, back up a step. Knowing that I have 3 zeros, I am looking for 3 zeros total. I don't know if they're imaginary or real, but I know if there's imaginary, there's only 2 of them, because you cannot have an odd number of imaginary. Okay, so keep that in mind. Maybe they're all 3 real, I don't know. All right, so I factored an x out. I end up with x squared plus 2. As long as I've got a quadratic factor, I can solve. So I know that x equals 0 for this one, and x squared plus 2 equals 0 for this one, which of course x squared equals negative 2, so x is equal to plus or minus I squared of 2 when I take the square root of both sides. So I have 3 zeros. I have 1 real and 2 imaginary. The 2 imaginary are the plus and minus I squared of 2. The 1 real is 0. Okay, so we just finished the problem. We solved it and stated what the number and types of zeros there are. All right, let's go to 1B. I know I can factor this by using difference of 2 squares, x squared minus 4 and x squared plus 4. I know that this is x minus 2, x plus 2, and this is x squared plus 4. I know out of the 4 zeros that I'm looking for, I know 2 of them are real because x equals 2 and negative 2. I know that when I set x squared plus 4 equal to 0 and solve, I get x squared equals negative 4, x equals plus or minus 2i. I know that 2 are imaginary. So those 2 are imaginary, those 2 are real. So remember, you start off with the same number of zeros as degree, and then you solve it. We don't know if they're real or imaginary to start with, but when we get done or get close to solving, we can tell, obviously this one's going to have 2 imaginary because I'm going to end up solving it and getting a square root of a negative. Okay, so let's try this one. Let's go looking at factoring by grouping. This does not factor by grouping. Okay, so maybe I'm going to use this one by using the calculator. When I use the calculator on this one, I end up seeing on my table, on the calculator, -5 is a 0, -1 is a 0, and 2 is a 0. Okay, so basically I found out of the 3 zeros, I know that 3 are real and 0 are imaginary. And the zeros, according to my calculator, are -5, -1, and 2. Okay, so that one was not too bad. This one does factor by grouping, so I'm going to go ahead and do that. I end up with x squared and 3x minus 1. Factor a plus 3 out, I end up with 3x minus 1. So that is x squared plus 3 and 3x minus 1. Looks like I've got 3 zeros, and I know that one of them is going to be real out of this one, because x is going to be positive 1/3. Out of this one, I'm going to end up with 2 imaginary, because you're going to subtract 3 to take the square root, you get plus or minus I squared root of 3. So those are my 3 zeros. I never would know what those imaginary are if I didn't factor. I'd have to factor to find those. Okay, so that's example 1. A, B, and C, and D in the book. Now let's go ahead and talk about the second part of goal 1. The second part of goal 1 is being able to determine the possibilities of the numbers of real and imaginary. The possibilities. Now, within these possibilities, we know we can determine whether those possibilities are going to be positive real, negative real, or imaginary. And here's the trick. It's called Descartes' rule. Okay, so Descartes' rule okay, just going to double check the camera. So according to this, Descartes' rule tells us the possible number of real, positive, real, negative, and imaginary. The number of possible imaginary. Okay, so here's an example. It's example 2 in your book. F of x equals 2x to the 5th plus x to the 4th plus 3x cubed minus 4x squared minus x plus 9. Now, at this point, we know that the total number of zeros, according to the fundamental theorem of algebra, the total number of zeros is 5, because it's a 5th degree. Now, what we can do is, if we analyze f of x, the number of sign changes of f of x, and I'm going to show you how to do that. The number of sign changes of f of x. Okay, so we look at f of x, which is right here, and we look at the number of sign changes from one term to another. The first term's positive, the second term is positive, the third term's positive. It does not change signs. However, there is one sign change. It goes from positive to negative. From negative to negative doesn't change, but from negative to positive does change. So there are two sign changes. What that translates to be then is there are possibly two positive real zeros. Or less than that by 2. So anytime you end up with a possibility of a number of zeros, you always take that number and then subtract 2 multiple times until you get to 0 or 1, something like that. So the possibly 2 real zeros or 0 positive real zeros. All right, let's go to the next one. Now we analyze the number of sign changes for f of negative x. Now, when you analyze f of negative x, basically you put in negative x in for x. When that happens, the only signs that change of the original, that changed from their original state, is the odd degree terms. So if I put a negative x in here, this now becomes negative 2x to the 5th. The x to the 4th stays positive x to the 4th because a negative to a 4th power doesn't change. The odd degree, this one changes to a negative. The quadratic stays negative. The linear terms changes to positive, and the constant stays positive. So I'm going to repeat what I just said. When you put negative x in for a function, the only signs that change from the original are the odd degree terms. All the rest of the terms stay the sign they are. Now we're going to analyze these sign changes. We've got one here, one here, one here. So there's actually 3 sign changes. Which translates into the possibly 3 or 1. Remember, we subtract 2? 3 or 1 negative real zeros. 3 or 1. So I know I've got at least 2 or 0 positive, 3 or 1 negative, and then we look at the imaginary. The number of imaginary. We know that we can't have an odd number of imaginary, and the degree is 5. So that means I could have at most 4 imaginary. So the possible number of imaginary, just by looking at this polynomial, is 4, 2, or 0. You can't have 5. Obviously I can't have 6, I don't have that many. But I could have 4 imaginary. I could have 2 imaginary. I could have 0 imaginary. Again, those drop by 2 every time. And they have to be even or 0. Okay, so that's Descartes' rule. That's something you should know how to do. Read it in the book. Let me know if you need help.